Hello friends, so today we gonna discuss this question from LeetCoding challenge problem binary tree maximum path sum. In this question you are given a non-empty binary tree. You have to find the maximum path sum. So a path can be defined through a set of nodes which generally does not need to pass through a root node. So as you can see in this can be assumed to be a path, this can be a path. So 3 plus 1 plus 2, this is 6. So you have to find out the maximum path sum. In this example, as you can see, this can also be a path, this can also be a path, or anything can be a path. So what you can do is, this is the maximum path as you can see. So the sum is 42. So you have to find out the maximum path sum. Okay. So let's make it clear with this example. We will start from the root node. We will go to the left, check whether it has a left child or not. Yes. We will again move to the left. It has left child. We will go to the left. Because the left child is not there, we move back and we tell that the value of this left child is 0 because there is no child. Then we move to the right. There is no right child. So we move back and tell that the right child value is also 0, left child value is also 0. So the maximum for this subtree rooted at -2 is -2 only. Maximum. So what we can say is, this is maximum is 2 -2. So for this subtree maximum -2, so we have to tell whether this is the maximum or not. So we maximize with -infinity, a very large negative number, and because it's less, we will tell the maximum is now -2. Okay, then we are back at here 4. Then we go to this right and we check the maximum here is -4. Okay, so the maximum for this subtree is -2, for this subtree is -4. So for 4 only, what can be done? Why should he take minus value with it? He can only be 4 himself only. So if there are negative values, we take it to 0 only because we do not want it in the final answer. And for this path, for this subtree rooted at 4, the maximum is 4 only. Now, so the same we do it for here. Now for 5, our loop goes back because we first find out the left subtree value, maximum value, the right subtree value, maximum value, and we add it to its root node and find what's the maximum for the right and left plus this. Okay, so we find out that the maximum for this subtree is 4 only, and we send this value back to its 5. Sorry, it's 4. We move to the right, and then what we have to check is some left exists. Yes, left exists. No, so we return 0 for the 0 for this left subtree of rooted at 7, and also 0 for here. So the maximum is 7, which is better. So we make it 7. I can also update it here only, which is 4, and then it becomes 7. So first it goes to 4, then it becomes 7. Okay, then we move back to here, then we move here, and we find out that the maximum for this is 6, but this is not greater, so we remain it as 7 only, and we return the maximum. And for 3, the subtree rooted at 3, the left subtree has a maximum value of 7, the right subtree has a maximum value of 6, and its value is 3. So total will be 7 plus 6 plus 3, which is 16. So we will increment the answer, and what we will send back for each node is its value plus the maximum of the left and right subtree, because we have to find out a path. So if there is a path which ends at here only and both are negative, we will only send this value because these become 0. But these are positive values, so that's 7 and 6. We find out the maximum of them and we will add them because we have to find out a path. We cannot take both. So we take 7 plus 3, which is 10, and send out that maximum rooted at this is 10. So and here comes 4, so it is 14, which is smaller, so the answer is 16. I hope you understand the logic. So let's code it and it will become more clear. So we want a maximum, global maximum. We make it maxi and initialize it a very less negative number. Then we will do a DFS call on the root and return maxi. Okay, we make a DFS function which take node root. Okay, if root is null, so if root is null, we have to return 0 as I have told you. Else we will find the maximum sum of the left subtree. Left is equal to DFS. Okay, so because if it returns 0, so we have to find out the maximum of left subtree, which is left, and the right, which is DFS right. But if this DFS returns a negative value, then we want it to be 0 only, because we don't want to include a negative value in an answer. So we want to find out the maximum of 0 comma this DFS return value, which I have told you in the concept. You can again watch why we want it to be 0. Okay, after this we want to check if left plus right plus the root value, because we also have to include the root value, is greater than maxi. So maxi is equal to left plus right. It's better to store because we don't have to compute again left and right value. Root left and root value. And then what we have to return is the root value plus the maximum of left plus right, which I've also told you in the concept. And that's the answer. Let's submit it. Okay, let's first connect. Maximum of left comma right. So it's accepted. I hope you understand the logic. If you still have any doubts, please mention down. Thank you for watching this video. I'll see you next one. Bye.